Hello everyone. So we are solving binary search questions. So let's start with question number two because question number one we already solved in previous video. So let's go to question number two and let's see what it says. Okay, find first and last position of the sorted array. Given an array of integer nums sorted in non-decreasing order, means it is increasing order. Find the starting and the ending position of a given target value. If target is not found in the array, return -1 and -1. You must write an algorithm with log n runtime complexity. Okay, so let's understand the question first. What let me take an example. It says we are given an array. What is it? Array 5 7 7 8 5 7 7 8 8 and 10, and we also given a target. What is target? Target is 8. So we have to find the first occurrence in array of target. Like in this case the first occurrence is this, and we also find last position, or the last occurrence of 8 will be this. So if I'm going to index this 0 1 2 3 4 5, the answer what is expecting 3 and 4. So yes, they want me to return index of first. This is the first and this is the last occurrence of the target. So how we are going to do that? Just simply binary search. And how we are going to binary, because it is sorted. First thing is sorted. Let me remove sorted, so we can apply a binary search. Of course I'm not going to tell brute force approach. You can just go you can apply a one loop. It will go find the first character. If we will find the first character, then we will stop, and then we'll go until then. You can start a loop from the end, and whenever you find a element which is equal to target, then again stop and then return the first and the last. And this is the brute force approach. But we have to find we have to solve this problem using binary search. Because it is sorted, we have to utilize this thing. How we are going to do? Like for the first occurrence, what we are going to do, like 5 7 7 8 8 and 10. What we do generally in binary search, we will fix a low and high. This is the showing a search space. Like from here to here, it is my search space. I want to search the target element from the low to high, including low and high. Okay, so in this we will find the mid value. So let's suppose the mid value comes like this 2 is the mid value. So let's take this is the mid. Suppose my target value is 8. That means 7 is lesser than 8. That means we have to find in the right. Left will be discarded. Okay, so we will find in here. So let me erase this thing and again mark low. Now low is pointing to here and high is same position. So my search space now reduced to this much. Now I'll search 8. So if I calculate for now mid value, the mid value comes to this. This is mid. Now it is equal to 8. Now we will not stop because we have to find first occurrence, and we have to find first occurrence. We will store it into our answer. Like whatever index it is, we will store it into our answer, and then we will move its left. Why we will move its left? Why will not right? Because it is equal and it is sorted. That means if we will go its right part, let's say this is my mid, okay, and if since the given array is sorted, that means there might be an element or 8 present in the left side, and we have to find the first occurrence, so we have to move the left side. If we move right side, then we will lose this left side element and we will never reach this the first element, first occurrence of the target. So that's why we have to move its left for the finding first occurrence. Then what's about the last occurrence? We will do its coding as well so that you can understand better. Like if we want to find the last occurrence, then we will its move. Firstly, we will store the answer of this. Like whatever, if the target is equal to array of mid, then we will store the answer. Let me write pseudocode so that you can understand it better. So this is the function of in this we will take an array, okay, so fix the pointer of low and high as a 0 and -1 respectively, then iterate till low is equal less than or equal to high, okay. Now calculate mid. What is mid? Mid is high plus low divided by 2. Now we will compare this mid, array of mid, equal to target. If it is equal, that means the target is present in the array. So we have to find the first occurrence. It means that we have to move its left part, because first of all you have to store the answer. Let me initialize an answer variable. Initially it will store -1. This is the variable. I initially mark it as -1, okay. Now if the target is find it, then my answer would be mid, because we have to store the first occurrence of index we are going to store. So answer equal to mid, and we move search space to left part. Why left part? Because we have to find the occurrence. It might be present here at as well, 8 as well, so that's why we are going to, it might also present 8 as well here right hand side, but we don't want to find the last occurrence. So if we move here, then we will never find the first occurrence, so we have to move left side, okay. So we will move left side. How we will move? We will simply move the high pointer to the mid -1, high to mid -1, okay. If it is not equal, else if it is not equal, then we will compare array of mid. If array of mid is greater than target, if target is less than array of mid, what does this mean? That means target mid value is greater, so I have to find the value which is smaller in the left side. Let's say my mid is, let me create, okay, so let me write it over here. So my a will be 1 2 3 8 9. So this is my a. Now I have to find target. Let's say my target is 2 and my mid will this, my mid is 3, okay. My mid is 3, that means my 2 lies in the left side for sure. If it is not present, this is the another case, but 2 is going to be lie in the left half, this half. Why left half? Because 2 is less and the array is given as a sorted. Do you understand? 2 is less and array is given as a sorted, and mid value is 3. means if you go to search in the right part, then it's useless. Why useless? Because in this, in the right hand side, the element which is present is greater than 3 and our target is 2. So we have to find the target element in the left side. If it is present, then there is 100% surety that it is present on the left side. So I'll move my high pointer to mid minus 1. Okay, else there is only one case that array of mid is greater than or target. So if my target is, let's say, 5, sorry, okay, if let's say my target is now 5, now my mid value is 3. Now I have to search in the right part. Why right part? Because the mid value says that my element is 3, and in the right part, the element which is present in the right part is always greater than 5. If there is a 5, then it will be present on the right side. So how we will go to right side? My low is here, so I'll take the low and point this to mid plus 1. So it will be low equal to mid plus 1. That's it. After that, if my answer doesn't change, then it's obvious that my element is not present in the array. So if my answer equal to minus 1, that means uh, no element present, then we will return minus 1 and minus 1. We write this code. This code is for first occurrence of target. Okay, if the first occurrence, that means if my answer is minus 1, that means there is no element present in the, there is no target present in the array. So I'll simply return minus 1 without calculating the last occurrence, because there is no element present, no target present, then why we are calculating the last occurrence? So let's write a logic for a last occurrence, how we are going to calculate it. It's very similar. I'm going to explain what is the concept behind it, like 1, 2, 8, 8, 8 and 7. Okay, so my low is pointing to, initially low is here and high is here. Now let's say mid value is this. Okay, now the mid value is equal to target. Our target is, what is our target, is 8. Now our mid value is equal to the target. Now we have to find the last occurrence. So where we will get last occurrence, left side or right side? Obviously right side. One second. Okay, obviously right side, because the last occurrence you can see here. If the last occurrence is present, whenever we our target is equal to mid, then we will store that into our answer. And for this finding the last occurrence, then we will do opposite thing, like if we are doing like if array equal to target, then we are storing our answer into mid. Okay, then we are moving the high pointer to the minus 1. So in this case, whenever if my array of mid equal to target, then I'll store that into my that index into my answer, and I'll move my low pointer to mid plus 1. This is going right, going right? Remaining code as it is, which are written on the finding the first occurrence of the target, it would be same. These things only going to be changed. Okay, so if the target element, if we are finding the first occurrence, then if the target element is equal to array of mid, then we will move the high pointer to mid minus 1. If the last occurrence, if the we are finding the last occurrence, then we will move the low pointer to the mid plus 1. So this is the difference, nothing else. This is very similar to the binary search, finding the target element in the array. And let's see the code so you can understand better. So I have written a first occurrence. Okay, so this is the first occurrence function. I'll initialize a low value to 0, high value to minus 1. These are the indices. Okay, so iterating until low is less than or equal to high, calculating mid. This is the calculating mid if the target. Okay, so let me write it for you. This is another code, I think. And let's see. And let's create a variable called answer, initialize with minus 1. If my low is iterating low is less than equal to high, then calculating mid equal to low plus high divided by 2. If array of, okay, array of mid equal to target, then what we are going to do, store into our answer, that is answer equal to mid. Then if we are finding the first occurrence, then the mid, then now we are going to search into the left part. So how it will be, high equal to mid minus 1. Okay, okay, now else part, if array of mid is less than target, that means target is greater, so we have to search in the right part. So low equal to mid plus 1, else condition, there is only one case, so this will be mid minus 1. Okay, so this is the, and after that we will return answer. If there is no element present, then it will be automatically minus 1. Okay, for the second occurrence we will do same, answer equal to minus 1. As I said, I'll just copy this code so that you can understand, like writing the first occurrence and the second occurrence of, there is no difference. There is one liner code will be differentiate. Let me do that here. Going to left, here we will go to low equal to mid plus 1. That's it, and here I'm going to return answer. Okay, for the main function search range, I'll initializing n, and to that I'll just putting the size of the array, and then creating a vector answer or pushback, and then calling the first occurrence, then calling the second occurrence, and then returning the answer. Let's try to run this and see if it is running fine or not. Yes, this is correct, and let's submit this. Accepted. So that's it. Next we are going to do floor in sorted array. So thank you.